Good morning to one and all. Today we are going to see about the difference between the Gauss-Seidel, Newton Raphson and fast decoupled method. As in the previous classes, we have seen the algorithm for Gauss-Seidel method and the problems we solved a few problems in Gauss-Seidel method and as well as in Newton Raphson method and as well as the fast decoupled load flow method. So the first, what is the Gauss-Seidel method? Gauss-Seidel method is simple and easy to execute. Actually, the algorithm is very simple and easy to execute, but it consumes more time. More time in the sense it will consume more iterations or epochs. So whatever you call in your own language, but generally we call it as more iterations or epochs. So here as a number of buses increase, automatically the time taken to execute the program also will be more. So these are the advantages of the Gauss-Seidel method. Next, Gauss-Seidel method shows the highest number of iteration for convergence to the solution. As I said, it shows the highest number of iteration to converge to the solution if the number of buses is more and the iteration increases with the size of the network. So the size of the network, say for example, it is 40 bus system or 118 bus system. So like that, if the size of the buses goes more, then automatically the time taken for convergence also will take more. So you'll not feel while doing with your hand calculation, like for if you are doing with a 2 bus system or 3 bus system, if you program, that with the MATLAB or any Python programming, then you'll feel the time taken for the algorithm will be a little bit more if the size of the network goes more. Next, due to good computational characteristics, Gauss-Seidel method is useful for small system with less computational complexity. So if your problem is for small, if the problem is very small, then you can easily choose this Gauss-Seidel method. Whereas Newton Raphson method is most efficient and reliable one for fast convergence and accuracy than Gauss-Seidel method. So Newton Raphson method will be more efficient algorithm and also reliable one with compared to the Gauss-Seidel method and also fast convergence when compared to the Gauss-Seidel method. Next, Gauss-Seidel method for load flow analysis uses the sequential approach to update the solution. So it starts with the initial guess. As I said, the initial start is there now. Initial start, that is a flat start. That is voltage we are assuming as a 1 at the angle of 0. That is the initial start. And then solves one equation at a time. One equation at a time using the latest values of the variables. And also, this method is simple and easy to implement, and it does not require the inversion or factorization of the matrix. So if you see the Gauss-Seidel method, if you not understand the algorithm, you go back to my previous classes and you see what is the algorithm. It is very simple algorithm. It does not involve any factorization of the matrix. So in the Newton Raphson method, we are calculating the Jacobian matrix. We are going for the inverse of the Jacobian matrix like that. But in Gauss-Seidel method, there is no factorization of matrix or inversion of matrix takes place. So that's why the algorithm is very simple. In comparison with the Newton method and its variants, the Gauss-Newton method for solving the nonlinear square problem is attractive because it does not require any computation or estimation of second derivatives of the function f of x, and hence it is numerically more efficient. So in Newton Raphson method, as we have solved some problems, so in that what it is happening is we are going for differentiation, first derivation and as well as a second derivation. So in Gauss-Seidel method, there is no any derivative like first derivative, second derivative like that. Okay, so that is the main advantages of this Gauss-Seidel method. These are the advantages of the Gauss-Seidel method. So what are its limitations? However, convergence also depends on various factors such as the selection of slack bus, initial solution, acceleration factor, tolerance limit, level of accuracy of the results needed, type and quality of the software used. So we have seen in problems like a tolerance limit, we have set to the tolerance limit as a 0.001 and it depends on the problem. And also acceleration factor, we have taken alpha is equal to 1.6 and all. So it depends that convergence depends on the number of buses and the selection of the slack bus, initial solution, and as well as the acceleration factor, tolerance limit, and level and also quality of the software use. So if your program lines are more, say for example, if your program lines are 150 lines. Similarly, some users they programmed only for 50 lines. So which one will be better? 50 lines will be better, and it will converge fast, and the program computation time of the program also will be fast. So at that time, you need to go for the quality of the software use, and also quality of the software. Say, for example, if you do it in MATLAB programming, if you do it in the Python programming, which one will be compute fast in the sense? It depends on the user program. But generally, than MATLAB programming, Python is little bit fast. We can't say both are equal, little bit fast, some seconds. It will be fast. Next step, the slow convergence rate, the sensitivity of order of equation and difficulty in handling the PV bus and voltage control devices. So these are all the one of the factors which limits the fastness of this doing the program. Okay, so that is convergence of this Gauss-Seidel method. That is, it depends on the order of the equation. As I said, the Gauss-Seidel method not involves any second derivative and all. So it is little bit fast, and also say handling the PV buses, difficulty in handling that time also the slow convergence will be there, and also selecting the voltage control devices. So these are the limitations of the Gauss-Seidel method. It is one of the important 2-mark question you may expect in many semester exams. What are the difference between Gauss-Seidel method, Newton Raphson method, and fast decoupled method? Or sometimes they will ask only what is the advantages of Gauss-Seidel method and what are the limitations of Gauss-Seidel method also they may ask. So this is the very, very important 2-mark question that you may expect in your semester exams or in the exam.